Hello guys, welcome to the research presentation. So in this video, I will walk you guys through my research project, myself Gautam Bedi. So let's get started. So here are the agendas for this research presentation. So we will be discussing about research problem, and then we will discuss about the importance, proposed method, results, and future works in this presentation. Research problem. With the advancement in technology, improved underwater cameras and remotely operated underwater vehicles have been used by researchers to study marine life. However, a huge amount of data can be generated by these underwater cameras, and marine researchers have to watch the whole underwater video to filter the keyframes which contain marine life activity. Fish identification algorithms can be used to solve this problem. In this research project, we have tried to solve this problem using GRID, K-means clustering algorithm, to identify fish in the underwater videos. Importance. In this slide, we will look what was the main reason we did this research. With the help of the proposed method, marine researchers can save time and resources, which are usually wasted to filter underwater videos to find marine life activity. It can help researchers to speed up the research process and help us to get a better understanding of the marine life. With the help of the proposed method, the underwater video filtration process can be automated and helps to reduce the chances of human error in filtration process. So in this slide, we can look at the proposed method that we have suggested. So here, as you guys can see, like firstly, we get an underwater video as an input. So once we get the underwater video, we apply the background subtraction to that video. And once the background subtraction has been done, we convert the foreground images with background subtraction into grid. So with the help of the grid, we get the segments of that foreground image. And using K-means algorithm, we can classify those two segments into two folders. Fish folders will contain the segments which contain fish, and no fish folder will contain the segment which do not contain fish. So this is the structure of our proposed method. In the next part, we will be giving you guys the live demonstration of this algorithm. Thank you. So here is the live demonstration of the algorithm of the proposed method. So let's say, we will run this program here. So the moment we run this program, the fish video will start running. So this is the data set, which is basically just the video. So firstly, what will happen, the video will run. So algorithm will try to figure out the background. So firstly, let's say, once this algorithm is done running, it will basically generate a subtracted background, which we will be later subtracting it throughout the whole video. So let's just wait for this algorithm to run for a moment. So as you can see, the moment this one has finished, so this is the background which has been generated. So now what we will do is, inside the code, we will mark this background flag as false. So here we have marked this one as false, and now we will save, and now we will just run the algorithm again. So I have run the algorithm again, and now as you can see, like we have started generating the keyframes with background subtraction. So basically the algorithm will run, and it will convert the whole video into set of keyframes with subtracted background. So I'll just cancel it here. So as you can see, right, so this is the keyframe from the image, but it has a subtracted background. So now let's say now we are done with this subtracted background part. So just for the explanation purposes, what I'll do is I'll just paste it outside. Let's just paste it here. So this is the keyframe which I have pasted just now, and now we will jump on to the second part. So the second part is just second part we are just doing the classification, right? So what I'll do is, let me just run this algorithm. So when this algorithm runs, basically what happens is it just asks for like, please select the BMP image to be segmented. So let's say, this is the same image which we have kept.
before doing that, let me show you one more thing, guys. So if you go into fish classifier, so in the data set, as you can see, in we have two folders. So one is the segment folder. So this is the folder which will contain the segments of all of this foreground image, and here is the prediction. So right now fishes and no fishes folders has nothing, right? So now what I'll do is, so let's say, you know, I gave this image, and then it will ask me what's the grid dimensions that I wanted to give. So let's say I give 40 by 40 pixels. So when I give 40 by 40 pixels, it converted the image into CSV, so it generates all the thing. And now if we look at this segment section, so here you can see so you know, like all the images has been segmented, and we have generated the CSV file for all the segments. And now if we go to the prediction section, so in the prediction you can see we have detected wherever the algorithm thinks like it's a fish. And if we go to the no fish thing, so here you can see like everything which the algorithm thinks like it's not a fish, it's been put on this folder. So this is the proposed method that we have developed in this unit. So now if you want to check the accuracy as well, you can if you want to check the F1 score, you can also do that. So let's say we put 8. Let's say it's gonna ask you about the true, negative, true, positive, everything. So let's say you click enter, and then it straight away gives you what's the accuracy and everything. So the values which I have put right now, it's just for the demonstration purposes, so I have done this. So thank you.
So these are the results that we have generated by performing the experimentation. To perform the experimentation, we have used different grid sizes, and then we have calculated the precision recall and F1 score. To measure the performance of the proposed method, F1 score is calculated for the proposed method. The F1 score is a balance between precision recall, and it provides a single aggregate number that summarizes the performance of the model. So as you guys can see in this slide, for 40 by 40 pixel, we were able to achieve an F1 score of 0.51. So this is the maximum F1 score that we were able to achieve in this with the help of this experimentation. Here is a list of future works that can be done in future. Different background subtraction methods can be utilized. Support vector machine algorithm can be used instead of using k-mean clustering algorithm. Different grid sizes such as 10 by 20 pixels, 10 by 30 pixels, etc. can be utilized to measure if they have any effect on the F1 score of the proposed method. Neural network algorithms can be utilized to identify the fish in the underwater videos. We have reached at the end of this presentation. I hope you guys enjoyed this presentation. Thank you, Gautam Bedi.